Hey everyone, in this video we are going to solve the populating next right pointer in each node on Leetcode. So what the question says is we are given a balanced binary tree, a perfect binary tree, which means it's perfectly balanced. Every node other than the leaf nodes have exactly two children. And what we need to do, we need to point the next pointer to its next right node. What does that mean? So the node to its right side. So in case of root node 1, there's nothing to its right side, so it's pointing to null. In case of node 2, there is node 3 on its right side, so next pointer is pointing to node 3. In case of 4, there is 5 on its right side. In case of 5, it's 6 on its right side. In case of 6, it's 7 on its right side. And in case of 7, there's nothing on its right side, so its next pointer is pointing to null. So this is the question. Let's see how we can do it. So the first solution that may come to our mind is to use some sort of a level order traversal. So what we can do, we can traverse we can traverse this binary tree level by level. That means first we'll go to the first level 1. There's nothing to it, so 1 will point to just null. One's next pointer will point just to null. Similarly, for the next level, we will have 2 and 3. So what we can do, we can point 2's next pointer to 3, and since nothing exists after 3, we can simply point 3's next pointer to null. Similarly, we can do for 4, 5, 6, 7 as well. So the time complexity for this one will be O of n, and the space complexity will also be O of n. So we can use this approach to solve this particular question, but there's another way to solve this question as well, in which the time will be O of n, but the space will be O of 1. Let's see how we can do that. So we are not using any level order traversal. We are just doing a normal BFS. So what we can do here? So we know for root node, its next pointer will always point to null as there's nothing right to it. But for 2, we can simply point 2's next pointer to root dot child. If we are at this root node 1, what we can simply do, we can simply write root dot left dot next to root dot right. By doing so, we can simply connect 2's next pointer to 3. Similarly, for 4, if we are at node 2, we can simply use uh, 2 dot left, which is 4 dot next to root dot right, that is 5. So by doing so, we can connect 2 to 3 and 3 and 4 to 5. But the challenge will come when we come to node 5 and we need to connect it to node 6, because we are at this particular node 2, and it does not have access to this node 6. This might seem tricky, but the solution is quite simple. Remember, we have already connected 2's next pointer to 3. So to connect 5 to 6, all we have to do is to move to the third node, to the next of node 2. What do I mean by that? So we can simply point 5's next pointer to 2's dot next dot left. What I mean? So if the next for the root exists, so if in this case, yes, it does, 2's next is 3. So to point 2's right node to 3's left node to connect the next pointer, what we can do, we can write root dot right dot next. So here we are connecting the fifth node, and we need to connect it to node 6. How we can get up to node 6? We can do root, which is 2 dot next. Now we come to 3, and then its left child 6. So by doing so, what we'll be able to do, we'll be able to connect this 5 node to node 6. So to connect this, what we did, we are at the parent. So that is the main thing to remember. We are at the node 2, and to connect its right child next pointer to 6, first traverse to 2's next pointer. So 2's next was 3 and 3's left was 6. By doing so, we simply connected 5 next to 6. So let's try run this solution once and you will get it clearly. So let's try run this our algorithm. So we are at the root node 1 and we don't need to do anything here. So because it's the root node and here it will just point to null. Now we need to use two pointers here. Let's say we have two pointers. One is current, which is pointing to our root node, and another is next pointer, which is pointing to its left child root current dot left. Now we need to apply this algorithm to connect all the next pointers in this particular tree. So to do so, first start with the left child. So root dot left dot next will point to root dot right. So current here root is our current. So current dot left dot next. So 2's next will point to current dot right. By doing so, we just connected 2's next pointer to 3. Now we need to do the same thing for the right node, but remember here root dot next we need to point it to root dot next, but in this particular case root dot next does not exist. So before applying this second algorithm, the second line of code, we first need to check if root dot next exists or not. In this case it doesn't, so we'll not do anything and we'll just move forward. Now once we are done with this right node as well, what we need to do, we need to swap this current and next pointer. So now this current pointer will point to where next was pointing, and next will point to its current dot left. So once we are done, what we are doing, we are moving current pointer to next pointer and next pointer to current dot left. Cool. So now we are at the last level, the third level. Now we need to apply the same algorithm here as well. So first for the left part, so current dot left dot next. So current is 2, left its left is 4. So current dot left dot next, it will point to current dot right. Current dot right is 5. By doing so, we just connected fourth next pointer to node 5. Now we need to do the same thing for the right child as well. And in this case, root dot next does exist. So root dot next dot right, root dot next dot right, which is fifth right, it will point to root dot next dot left. Remember, this 2 doesn't have direct access to this sixth pointer, but we have already connected 2th next pointer to 3. So we can use this previous connection to connect its right child to the respective next node. So applying this algorithm, what we can do, root dot right dot next, it will point to root dot next, which is 3 dot left. So by doing so, we just connected 5's next pointer to node 6. Now there are still nodes remaining, so what we will do, we'll just move the current pointer to its next current dot next. So we'll just move current equal to current dot next. Now current will come to its next pointer, so it will come to 3. So here next will also point to 6, which is current dot left. So current is pointing to current dot next and next is pointing to current dot left. Okay, now we are at the node 3. Now we need to apply the same thing, these two lines of code for this particular node. So root dot left dot next. So root is 3, its left is 6, its next will be pointing to root dot right, which is 7. So here we connected 6 to 7. Now we need to apply the second algorithm, but remember its next does not exist. So root dot next does not exist here. So we'll not do anything and keep the next pointer will simply apply to null. So this was the solution, which will run in time of O of n and space of O of 1. So let's see how we can do it in code. Okay. So first we'll need our two pointers. First our current pointer. So current pointer will be pointing to root. And next we'll need our next pointer. So next pointer, next, it will first we'll check if root does exist or not. If the root does exist, then only we'll pick its left child, because remember the next always point to root's left child. else it will be null. Next we'll run a while loop, and it will run till either a current node exists or our next node exists, both exist. So inside this while loop, what we'll do, first connect the left child's next pointer to root.right. So our same algorithm that we discussed in drawing explanation, current.left.next will point to current.right. Now we'll check if current.next exists or not, because now we need to point, now we need to do the same thing for the right node. So to do so, current.right.next, it will point to current.next.left. Fine. Now, once we are done with this particular node, we'll just move one step forward, which is current equal to current.next. Now, if the current does not exist, the current.next does not exist. So if current dot, so now if current does not exist, we'll simply move both of our pointers. So current will point to next, and next will point to current.left. And at the end, we'll just return root. So if we run this solution, yes, it's working. Let's submit it. Yeah, it's working. So that was it for this video. Thank you for watching.